Hello everyone. Now we are looking into an experiment called two-wheeler chassis dynamometer. The aim of this experiment is to determine the condition of the vehicle to conduct different tests like performance test, acceleration test, the maximum speed test, and different gear speed test, load test, and finally the fuel consumption test. The operators which is required to perform this experiment are we need to have one two-wheeler and a chassis dynamometer and a software along with a system to show the output. So the introduction for a chassis dynamometer is very simple. The chassis dynamometer is also called as a rolling rod, a device used for vehicle testing and development. It uses a roller assembly to simulate a roll in a controlled environment, usually inside a building. So the chassis dynamometer is an experiment to be conducted under laboratory conditions inside a building. So if you see the constructional details, it has got three main parts which consists of a roller, a platform and additional frame. You can see that in the diagram, the below diagram. The roller has two purposes. First, to receive the power that provided by the wheel, and second, to absorb and to store this energy in form of angular velocity. In order to achieve optimum condition, roller inertia and roller RPM must be at the peak. So for the safety purpose, not to get any mechanical damages with respect to the equipment, the roller RPM is restricted maximum to 5000 RPM. So you can see this, the diagram or the picture here, where the two-wheeler will be carried out on the frame, where the front wheel is tightly clamped and the rear wheel of the vehicle should be on standing position with the roller. Now we'll be going to the working. So the bike is kept on the test bench and the rear tire is kept on the roller. As the vehicle is started and the first gear is engaged, the rear wheel of the bike starts rotating and the roller also starts rotating. A neon magnet is attached to the roller, that is, the Hall effect based sensor is placed near to the rotating roller so that it gets the pulse count. From this count, the RPM of the wheel is determined. That is the roller RPM that can be determined. After that, the RPM is converted to kmph, that is kilometer per hour, to get the speed of the vehicle. The time taken to reach 0 to 60 km per hour is displayed. See, this is 0 to 60 is it's an example has been set. You can go like 0 to 40 or 0 to 50 or 0 to 80 or 0 to 100, like that. It depends upon the testing person. So this is done by starting the count from the first pulse achieved during the start of roller rotation. The fuel economy is also calculated by giving a separate fuel tank in which 100 ml or 1000 ml of fuel is filled and the distance covered using the fuel is displayed in the display. Torque at each gear also be calculated by using the equation P is equal to, that is the power, equals 2 pi nt by 60, where P equals power of the engine, N equals speed in RPM and T is equal to torque in Newton meter. Hello everyone. Now we are going to see the experiment which is called as two-wheeler chassis dynamometer. This chassis dynamometer, sometimes also called as a rolling rod, it is a device used for vehicle testing and development. So it is basically done under the lab conditions. So it is a piece of the test equipment fitted with rollers for the wheels of a vehicle that is capable of providing drive input and also to measure the output such as power and torque at the wheels. Now we have placed the vehicle, the two-wheeler, on the chassis dynamometer. So you can see the standing over there. You can see this part. This is the rotating drum, where once the wheel starts to rotate, the drum starts to rotate. As the drum rotates, you can see the Hall effect sensor. This sensor senses the speed of the drum, the rotating drum. The front wheel of the bike is fixed properly, so there should not be any disturbance and there should not be any chances the vehicle to get fall. So it has been tightened and clamped properly. Yes, and you can see one more cable, the red cable, which is connected to the cable of spark plug, where this will indicate the engine RPM. Okay, so this will connected to the engine RPM. That reading can be taken out. And one more thing, reading, as I said earlier, the speed of the drum. Okay, the speed of the drum by using the Hall effect sensor, and these two are the Hall effect sensor connection and the spark plug connection, that is the engine RPM. These two will be given as input to the system. Okay, that will be seen in the software. Yes, this is what the digital display, the dyno, where it is connected to the system, and that in that you can open the software. Yes, you can see this part, the engine RPM and the roller RPM. So once we start and the vehicle starts, the wheel will rotate and you can see the engine RPM and you can see the roller RPM. So now the vehicle has started and you can see the wheel is spinning, the brake drum is spinning, and that you can notice, and you can notice here the RPM, the engine RPM and the brake drum RPM. Okay, that is what the fluctuation you can see. Okay, you can see that engine RPM and the roll drum RPM. Okay. So that's what you can notice, that the engine RPM and the wheel RPM or the roller drum RPM. So this is a very important experiment in lab condition, to be performed in lab condition. So this can be used for various vehicles as well. Even the four-wheeler is also there, where you can use the four-wheel chassis dynamometer. And so what we are using is a two-wheel chassis dynamometer. So this is used, the application of this is, you can notice the maximum speed in terms of gear ratios. See, for example, for first gear, how much the vehicle can go with respect to highest RPM or highest speed, and ultimately you can go for second gear and you can go for third gear and higher gears or lower gears, where you can see the speed limit with respect to particular gear ratios. And one more thing, the care has to be taken care, because this the vehicle is going to be stationary and the engine what you are using is going to be the air cooled engines. So there is no movement of the vehicle, there will be a heating issue. At that condition, you need to provide then additional amount of air for cooling purpose by using some air compressors, and you can blow the air to the engine. So that care has to be taken. And similarly, as you can check the speed of the vehicle with respect to different gear ratios. You can also measure the fuel efficiency or the mileage with respect to other driving conditions. So that is one of the main application of using the chassis dynamometer. Okay, so this is what the experiment is. Okay. Thank you.